And welcome back, students. Today we are going to discuss stepping through a program, which is kind of a continuation of our debugging a program that we discussed last time. So let's go ahead and get started here. So we've already at this point seen our program run. We've run it and it's done some things. So we kind of have a general idea of how it works. But it doesn't really give us a good sense of what's actually happening inside of the LC3 during the execution of each instruction. It's much more interesting to step through the program line by line and see what happens as we discussed during our debugging lesson. Now you'll need this quite a bit in order to debug less than perfect code. So let's go ahead and try it. So stepping through a program, the very first thing we need to do is to reset the very important program counter to the first location of our program. So we set the PC back to location 3000. And we can either double click and enter a new value, or we can use the quicker method. Click on line 3000 and click on the blue arrow icon, which sets the PC location. Now we're ready to step through that program. Then we click on the step over icon, and you'll see a few interesting things happen. First off, R1 is going to get cleared. Right, if you cleaned up before clearing R1, this is not really going to be too exciting. The blue arrow and the PC both point to location 3001 now, which is the next instruction to be run. And the instruction register now has the value 5260. If you look at the hex value of location 3000, that's also 5260. The instruction register holds the value of the current instruction. Since we finished the first instruction and haven't yet run the second, the first instruction is still the current one, so it's still going to say 5260 inside the instruction register. Then if we click on the step over icon a second time, we'll notice that there are new values for the program counter and the instruction register. The second instruction clears register 4. If we click step over again a third time, the program counter and instruction register update once again, and now register 4 holds the value 0A, which is decimal 10, the number of times we need to repeat our loop to add 10 numbers. This is because the instruction, which is just executed, added 000A to 0000 and put the result into R4. If we continue to step through our program, we can watch the results of each instruction, and therefore we can kind of watch to see, making sure that they're the values we want them to be. This kind of gets into the whole tracing of the program. If at any point you want your program to finish executing in a hurry, we just click on the Run Program button, and that will cause your program to execute until it reaches the breakpoint you set in the halt line. Right? So that concludes the notes there. Let me just quickly go ahead and we're going to bounce over to the LC3 simulator here. And I've loaded up addnums1.obj, and I put my breakpoint there at line 3009, which has my halt command. And what I'm going to do, and remember we want to make sure our program counter is set to 3000, which it is, so I don't need to do anything there. And what I'm going to do is, rather than just hitting run, I'm going to hit step over. So when I hit the step over command, it's going to update that. Now we should see our instruction register update to 5260 as I mentioned before. So I click that once, and you can see that now the instruction register has the value 5260, which was the value here. All right. Again, you see there's nothing going on here at R1 or any of those other registers because those are all still currently set to 0. So if I do my second step, again, nothing happened here other than the instruction register got updated and the program counter got updated. Now, we should, when we click the next line, expect to see some stuff start to change. And when I went down to this line, it took this line that was in 3002, and you can see that register 4 now has the value of 10. And I can keep clicking through this. So if I click again, if I hit step over, right, it went ahead and ran that, and it says breakpoint encountered. So there it went. It just went execute through that line of code. And you can see there is the familiar information that we would expect before. And that's our program. Right. Of course, I can also just reset, reinitialize the machine. And if I go ahead and just reload that program, I'm just going to add nums2, which is the exact same program, just it was the hex version. If I go ahead and put my breakpoint in there, And I can step, 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 and you can watch as the code changes line by line. Of course, if you hit the run program, it will do the same thing as it did before. It'll run and hit the breakpoint. All right. That concludes this lesson, folks. Until next time.